Okay, so question 4, under investment decision, they are saying which of the 3 projects shown in the table below is the best investment if the interest rate is 20% using which of the 3 projects shown in the table below is the best investment if the interest rate is 20% using. So we have 3 projects in here. There's project A, project B, and project C in the table. Then they want us to say which project is more nice or which one is the best between the 3. So using these methods that they have put here. So investment decision is just about the decision about the investment. So you can use the NPV way to make a decision about a project, if you should invest or not. You can use payback period, you can use benefit cost ratio. So yeah, so for A, they want us to choose the project which is better using NPV. Then for B, using payback period. For C, using benefit cost ratio approach. Then for D, discounted payback period approach. Then for E, they are saying define the term internal rate of return and further calculate project B's internal rate of return. Okay, so we have the table here. So we can start with the first question. We make a decision using the NPV approach. So what you are supposed to do here, it is to find the NPV for each project. So you find the NPV for project A, you also find the NPV for project B, you also find the NPV for project C. Then you choose which one has a better NPV. Then it's the one that we can invest. When we are done with NPV approach, we go to payback period. We do the same. We find the payback period for project A, for project B, and for project C. Then we choose. So in each method, we have to choose one project. Okay, so let's start with the solutions for A. For me, what I'm going to do, because my space is not a lot, I'll be answering for one project. But you're supposed to answer for all the projects, since when I do for one project, you'll be able to know the process for doing the other projects. So in my case, I'm going to choose project B. So I want to answer everything for project B. But for you're supposed to answer for project A, project B, and project C. Okay, so the first question, they are saying using the NPV approach. So we want to choose which project is better using NPV approach. So how do we find NPV? So NPV is given by negative cost, then plus C, the present value. So this is the formula for NPV. Negative cost plus the present value. Okay, so meaning, what is the cost for project B? So the cost is how much you spend like investing on it. So our cost is 40,000, so we are going to put negative 40,000, then plus, so present value, we need to find the present value for project B. So what do we know about the present value? What's the formula? So the formula for present value, it's given by present value is equal to, it's cash flow T over 1 plus R to the power T. So that's the formula for present value. Cash flow T over 1 plus R to the power T, where cash flow T is just standing for the number of cash flow. If it is cash flow number 2, then we'll say 1 plus C, the interest rate, to the power 2 here. So this is the formula for present value. Now when you check for project B, we only have the cash flow in year number 1, which is 15,000, in year number 2, which is 20,000, and in year number 3, which is 25,000. Going down, we don't have anything, we just have 0, 0, 0, 0, 0, 0, 0. So we are going to find the present value for all those cash flows that are there. Okay, so we can start with the first one. So the first one will say, since the formula for present value is this one, so imagine I've already put the formula. So the first cash flow that we have, it's 15,000, then over 1 plus, what's our rate from the question? We have been told that the discount rate or the interest is 20%, so in decimal points it's 0.2. Then to the power T, what's our T? It is 1, because it's our cash flow number 1. Then we go to cash flow number 2. What do we have? We have 20,000 over 1 plus 0.2 to the power 2. Okay, then plus the cash flow number 3, 25,000. Then we are dividing by what? 1 plus 0.2 to the power 3. Okay, so we are trying to find the present values for those cash flows. So we can proceed. So when I do here, I have negative 40,000, then plus here my present value. So when I add down, so I'm going to have like 15,000 over 1.2 to the power 1, plus here I have 20,000 over 1.2 to the power 2, then plus the other one I have 25,000 over 1.2 to the power 3. Okay, so I can deal with this and see what I'm going to have. So I have negative 40,000 plus here 1.2 to the power 1 divided by 15, so it's giving me 12,500 watts. Then plus I do the next one, 20,000 over 1.2 to the power 2, it's giving me 13,008.89. Then plus I do the same for the next one, 25,000 over 1.2 to the power 3, it's giving me 14,467.59. Okay, so now since I have this, I can punch everything on the calculator together. So I'll say equal to 40,000 plus this plus this plus this, and see what we are going to get. So when I do that, it's giving me positive 856.48. So this is my net present value for project B. So now the way it is, if you want to make a decision using net present value, when you find and you realize that your NPV is positive, then you can invest. So after you calculate to find that your NPV is positive, then you can invest. If your NPV is negative, you do not invest. These are the laws that we follow under NPV. So if your NPV is positive, you invest. If it's negative, you do not invest. So what we have found for project B, we have found a positive NPV. It means we can invest. Okay, so now you need to do the same. You find the NPV for project A and B using the same formula. So since for project A you have the cash flows that are going maybe up to year 6 or year 7, so you just keep on adding this side. So after to the power 3, you say the cash flow that is there to the power 4, power 5, then power 6. Yeah, so that's how you do. You find the NPV. So maybe let's say project A, you find like the NPV is positive 400. Then project C, you find that the NPV is negative 100. So meaning we can choose project B because it has a larger NPV. So if you have two projects that have a positive NPV, you choose the one that has a bigger NPV. Okay, so that's about A, where we are using the NPV approach to make the decision. Then for question B, they are saying using the payback period, make a decision using payback period. So how do we make a decision using payback period? So for using payback period, you need to come up with a table, maybe if I say. So let's do question for B, where we want to use payback period. So you can come up with a table, you say yeah, then here we are going to put the cash flow, then here we put cumulative. So this is the table that we are trying to come up with. So for the years, we have year 1, we have year 0, we have year 1, we have year 2, and we have year 3. Okay, so in year 0 we don't have any cash flow, but for the cumulative here, it means how much have you invested in the project. So payback period, it's just the time it takes for you to recover whatever you invested. How long will it take for you to recover what you invested? That's what we call the payback period. So cumulative here, we invested 40,000. So you put it in brackets to show it that it's a negative. So anything in negative, it means it is just the amount that you invested. Okay. So in terms of the cash flows, we have seen that in year 1, for project B, we are receiving 15,000. So we'll put 15,000. Okay. Then in year 2, how much are we receiving? We are receiving 20,000. Then in year 3, how much are we receiving? We are receiving 25,000. So these are the cash flows that we have. So now we need to finish the cumulative also. So for the cumulative, what we invested 40,000 in year 1, we received 15,000, so we need to subtract it from this. So we'll be removing from this, so this amount will keep on reducing. Now because this is a negative, so we'll be adding, we'll be saying negative 40,000 plus 15,000, which is just the same one subtracting. So negative 40,000 plus 15, after the end of year 1 will remain with 25,000 from what you invested. You are recovering the money. Then for year 2, negative 25,000 plus 20p will remain with negative 5,000. For year 3, negative 5,000 plus 25p, we are going to have positive 20,000. Okay. So in terms of knowing the payback period, so in the year in which your cumulative turns into positive or it becomes 0, that's the year we call payback period. So in this case, our payback period is 3 years, because in year 3, that's when our cash flow has become positive. Okay, so we'll say payback period for this project is 3 years. So payback period is 3 years, because in year 3, that's when our cash flow has turned into positive. So that's how we use payback period. If it turned positive into year 2, we could have said our payback period is in year 2. So when it becomes 0 here or positive, then that's your payback period. Okay, so let's go to, you have to do this for all the projects. You do this for project A and project C. So me, I'm just doing everything for project B, but you need to do for all the projects. So you're going to compare. So how we make an investment decision using payback period? A project that has a shorter payback period is the one that you choose. So for example, project B, we have found that our payback period is 3 years. Maybe project A, you have 4 years. Project C, you have 8 years. So we can choose project B because it has a shorter payback period. Okay, so that's about it. Payback period. Choose a project that has a shorter payback period. Okay. Then let's go to 4C. So for 4C, they are saying we use benefit cost ratio to make the decision. So we want to use benefit cost ratio. So benefit cost ratio. Okay. So we want to make a decision using benefit cost ratio. So what's the formula for benefit cost ratio? So the formula is simple, just the same way things are. Benefit cost ratio. So on top, it's the present value of benefits. Present value of benefits. Present value of benefits over the present value of the costs. Present value of costs. So this is the formula for benefit cost ratio. Present value of the benefits over the present value of the costs. Okay. So now, what are the benefits? So the benefits is what you are receiving after you invest. So we have seen that for project B, in first year we are receiving 15,000, in second year 20, in third year 25. So those are the benefits. So we need to find the present value of all the benefits, then we add on top. Then down, the present value of the costs. So we are going to find the present value of the amount that you invested. Okay, so let's find the present value of the benefits. So since from what we started, we already found the present values. If you remember here, what we were doing, we were finding the present value of 15, 20 and 25, and we found them to be these are the present values. So we are just adding this one, and this one. Then this is what we are going to put on top here as the present value of the benefits. Okay, so the benefits that we have, our first present value, it is 12,500. Then plus the next present value, it is 13,088.89. Then plus 14,467.59. Then we are dividing by the present value of the cost. So since we only have, like when we say the cost is how much you invested, so the present value of the cost is the same amount since it's just in year 0. Okay, so we have 40,000 as what we invested. So when I add what's on top, and I divide by 40,000, it's giving me 1.02 as my benefit cost ratio for project B. So for me, I'm answering everything for project B. You need to do the same for project A, for project B, and for project C. Okay, now how do you make a decision? How can you choose to say, let me choose this project using benefit cost ratio? So the way it is for benefit cost ratio, any project that has a benefit cost ratio which is above 1, you invest. If the benefit cost ratio is above 1, you can invest. So like the way it is for B, it's above 1, you can invest. So you will do the same, you will see what you get for project A, project B, and project C. So now let's say maybe 2 projects, they have a benefit cost ratio that is above 1. You choose the one that has a bigger value. So if B is the one with a bigger value, then we can invest in B. If it is C with a bigger value, then you can invest in C. So that's how it is using benefit cost ratio. Okay, so with this being said, we can now go to question 4D. Okay, so for D, they want us to make a decision using discounted payback period approach. So what is discounted? So discounting is the process of converting the future values into present values. So discounted payback, it's a situation where the cash flows that you have, the 15,000, the 20 pin, and the 25, you first convert them into present value. Then you use the present values to come up with the payback period. So what do I mean? I'm going to have a table. So we are answering question 4D. So I can have a table for here. Then we have cash flow. Then we have present value here, and the cumulative this side. So this is how a table for discounted payback period will look like. So for the years we have 0, 1, 2, 3. Okay. Then for the cash flows in year 0, of course we don't have anything. Then in year 1 we are receiving 15,000. Then in year 2 we have 20,000. In year 3 we have 25,000. Okay, so now using discounted payback period, we need to convert these ones into the present value because they are saying discounted payback period. So we can find the present values of these, of which we already know the present values we did when we are trying to come up with NPV. So the present value for this one we had found 12,500. Then for 20 pin, the present value that we found was 13,088.89. Okay, then for 25, our present value was 14,467.59. Okay, so now when you do that, what you are going to do now, so for year 0 we don't have any present value. So for the cumulative, this is where we put now how much we invested. So in this case we invested 40,000 for project B. Okay, so we are putting it in negative because payback, it's about recovering what you invested. So now we want to see how long it will take for us to recover whatever we invested. Okay, so now we won't be subtracting these cash flows, but we'll be using the present values for discounted payback period. So we invested 40,000. What about after 1 year? How much are we going to remain with? So we'll subtract 12 from this. So we are saying negative 40,000 plus 12,500, which is giving us negative 27,500. So negative 27,500 plus 13,800, we are going to have negative 13,611.11. Okay, then now this one, negative 13,611 plus this for year 3, we see how much we're going to have. It's giving me positive 856.48. Okay, so we have seen that after year 3, that's when our cash flows or our cumulative is turning into positive, meaning the discounted payback period for project B is 3 years. Okay, so what are we saying? We are saying the discounted payback period for project B is 3 years. So you do the same for the other projects, project A and C. So you come up with their cash flows, you find their present values, then you do the cumulative, of which for the cumulative we are just saying negative 40,000 plus 12,500 you put here, negative 27 plus this you put here, negative this plus this you put here. So our discounted payback period is 3 years, because in year 3 that's when our thingy is turning into positive. Okay, then how do you make the decision? So it's the same. The project with a shorter payback period is the one that you are going to choose. So that's so for D. Then we can go to E. So for E, they are saying define the internal rate of return and also calculate the internal rate of return. Okay, so the internal rate of return, it is just the value of R, or it's the discount rate that makes the NPV to be 0. So we are saying it is the discount rate, that makes the NPV to be 0. So that's the internal rate of return. It's the discount rate that makes the NPV to be 0. So if you want, you can use any definition to define the internal rate of return, or you can say it is the value of R that can give us a 0 NPV. So any definition, you are okay. So now they are saying we should also find the internal rate of return. So now what is the formula for finding the internal rate of return? By the way, this is question 4E. Okay. So the formula for finding the internal rate of return, it's given like this. Internal rate of return is equal to capital letter A plus small letter a over small letter a plus b. Then we are multiplying by capital letter B minus capital letter A, you close. Okay, so this is the formula for the internal rate of return. Yeah, so now what does capital letter A stand for? So capital letter A, it stands for a percent that is going to give us a positive NPV. Then small letter a, it stands for the value of a positive NPV that you find. Capital letter B stands for a percent that is going to give us a negative NPV, while small letter b stands for a percent that's going, small letter b stands for the value of a negative NPV that you find. Okay, so coming up with the internal rate of return is just a guesswork. It's a try and error method. You think of a percent, n% that you're like, okay, let me think of a percent that can give me a positive NPV. So because when we started answering question B, if you remember the first part, we are using the NPV approach to make a decision, and what we found was 856, which was a positive NPV. So capital letter A, we can say we have already, because we managed to find when we were using 10% for question A, when we were using 20% for question A, it gave us a positive NPV. So our capital letter A, will say is 20% because it's the one that gave us a positive NPV. Then our small letter A, it is the value of the positive NPV that you get. So from question A, our NPV was 856.48. So this is our small letter A. So now our goal is to find capital letter B. So we want to find capital letter B. Okay. So capital letter B, we said it's a percent that is going to give us a negative NPV. So now the way it is, since it's try and error method, so when, for example, our positive NPV is being given by 20%. So now to get a negative, you need to increase the percentage. So we can take the percentage to, the higher you go up, then the NPV becomes negative. So if you increase the percentages, your NPV is becoming negative. If you start reducing the percentages, your NPV is becoming positive. So that's how it works. So let's try to find the value of B. Okay, so me, I can assume maybe my B, let me choose 40%. Okay, so I'm choosing B to be 40%. So let's find the NPV. So we know that NPV is equal to negative cost plus the present value. So I've chosen my B to be 40%. So what is my cost? I have negative 40,000. So I'm only doing for project B, but yeah, and they have said we're only doing for project B, the internal rate of return. Okay, so plus, what are the formula for the present value? We said is cash flow T over 1 plus R to the power T. So our first cash flow, what we have is 15,000 over 1 plus R. So R in this case we have chosen 40%, so we'll say 0.4 to the power 1, and then plus our second cash flow is 20,000 over 1 plus 0.4 to the power 2, then plus our last cash flow is 25,000 over 1 plus 0.4 to the power 3. Okay, so when I say negative 40,000 plus all this, when I punch on my calculator everything, it's giving me, what am I? Okay, so it has given me negative 9,970.84. so this is what I've found. So it means we can use 40% as B. Why? Because it has given us a negative NPV. So that's how it works. You just try and error method. So if you want here, you could have tested R to be 30%. So you could have put 30% here. Then you see what you get. If it gives you a negative NPV, then you can accept the 30% to be capital letter B. So now looks like we have all the data that we want. Our capital letter B here, we have found it to be 40%. Okay, then our small letter B, we have found this figure here, so you ignore the sign. Okay, so 997.84. so when you are putting this figure on the formula, you ignore the sign. Okay, so now we can proceed with finding the internal rate of return. Since we know that the formula for internal rate of return is this one, we can replace into the formula everything that we have. So our capital letter A, what do we have is 20%. So we are putting 20%, then plus. Okay. What's our small letter A? So we have 856.48 over small letter A, again the same 856.48, then plus small letter B, we have this 9,970.84, then we are multiplying here by B minus A. So our capital letter B is 40% minus small letter A, capital letter A 20%. So here when you are putting the percentages, no need to convert them, you just do them the way they are. Okay, so we can proceed. We are trying to find the internal rate of return. So here I'll add everything that is down and divide into this. So first I have a 20% here, then plus. So when I divide here, then I multiply with 40 minus 20, it is giving me 1.58%. So I can add the 2, which is going to give me 21.58% as my internal rate of return. So the internal rate of return may not be the same. There are minor differences. Maybe someone can find 21.4, 21.6, 21.57, because it's just try and error. Maybe you chose another percentage, but it's just in the same range. Yeah, so that's about the internal rate of return. So in the case maybe we didn't even have the A, we could have found also just by try and error method. You think of a percent, you try to find and see what it's going to give you as the NPV.